Alright, in this video we're going to review Unit 2, which is about differentiation. So when we first got introduced to derivatives and instantaneous rates of change. Let's start by looking at some multiple choice questions. So our first question is a calculator question, so make sure you've got your calculator nearby. And it says, let f be a function given by f of x equals 2 to the x to the third. Selected values of f are given in the table above. If the values in the table are used to approximate f primed of 0.5, what's the difference between the approximation and the actual value? So notice we're going to need to find two values. We're going to need to find the approximation, and we're going to need to find the actual value of the derivative. So remember that derivatives are all about rates of change. So if we're looking at an approximation, that's going to be our average rate of change. And the actual value is going to be the instantaneous rate of change. Let's start with average rate of change. Remember that average rate of change does not require calculus. So average rate of change would be f of 1 minus f of 0 over 1 minus 0. And notice that we want to use 1 and 0 because they sandwich the value we care about, 0.5. Okay, then I'm going to go ahead and plug in what I know. F of 1 is 2, f of 0 is 1. So I get that the average rate of change is 1. Now, it might be tempting to circle that as your final answer, but it's not your final answer. That's just the average rate of change. Now I need to find the instantaneous rate of change. So I need to actually take the derivative of my function, f of x. Now you guys probably and hopefully could do that by hand, but the chances of us making a mistake or just spending too long of it are too high. So let's use our calculator. You're going to hit math 8 to get you n deriv, and you're going to make it say d dx of your function. Oops, let me write this just how you're going to see it on your calculator, of x equals 0.5. So we're going to take a second, punch that into your calculator, 2 to the x to the third, x equals 0.5. The instantaneous rate of change is 0.5669. Just kidding. I put my decimal one place too far. 0.5669. So I just need to find the difference between those two. You'll notice, first of all, the actual value, is also one of your distractor answers over here. I'm going to go ahead and subtract these two, though. So 1 minus what I got there, and I should get 0.433. And that is my difference between my instantaneous rate of change and my average rate of change. Now, this is a great question for an AP exam because it tests both your knowledge of instantaneous rate of change and the average rate of change at the same time. Let's look at this one. Which of the following statements, if true, can be used to conclude that f of 2 exists? So the first one, the limit as x approaches 2 of f exists. If we know a limit exists, we know nothing about the actual point. A limit just tells us what's happening around that point. It doesn't tell us anything about it. So that's not going to tell us the function exists there. Now, if f is continuous at x equals 2, that's helpful for us. Because remember, if f is continuous, we know that the limit as x approaches 2 of f of x is equal to f of 2, which means that f of 2 has to exist. So that's definitely true. Okay. That would definitely mean that the function was defined at 2. Then if we know that f is differentiable at x equals 2, differentiable means that there's some derivative there. There's a slope. There's an instantaneous rate of change. If there's an instantaneous rate of change at any point, there's got to be a point actually there. So we can use both 2 and 3 as a criteria to decide if f of 2 exists. All right. The function f is given by f of x equals 1 plus 3 cosine of x. What's the average rate of change of f over the interval? Now notice it's asking for average rate of change. This is not actually a calculus problem, right? We know how to do average rate of change without even being in this calculus class at all. So make sure you know what type of change you're trying to find. To find average rate of change, we would have to find f of pi minus f of 0 over pi minus 0. Now, if you are not great with trig, or if you just want to avoid it at all times, this is it. Oh no, this is a non-calculator. Just kidding. I was going to say you can use your calculator, but you cannot. So we need to evaluate f of pi. So I have 1 plus, and then the cosine of pi, remember the unit circle, that's going to be clear on the left side, so that'd be -1. So that's my first piece. Minus f of 0. Remember that the cosine of 0 is 1 all over pi. Be really carefully evaluating this. You don't want to make mistakes with your trig. So you have 1 minus 3, -2, minus 4 over pi. So my answer is -6 over pi. So that's my average rate of change. Now if we had a calculator, or we could do this in our heads really, we could calculate some instantaneous rates of change along the way maybe. But we just need the average. Alright, let's look at some piecewise functions. If f of x equals that nice piecewise function, we're going to let f be defined as above, which of the following statements is true. And they're all statements about continuity and differentiability. So let's start by figuring out if it's continuous. So remember that continuity is a prerequisite for differentiability. That's an important thing to remember. So continuity is a prereq for differentiability. So if you lose continuity, you automatically lose differentiability. I'm sure I spelled that wrong, but that's fine. So let's check to see if it's continuous first. So we know that each piece on its own is continuous, right? We just want to see what happens when they meet up. So down here, I'm going to go ahead and show some work. I'm going to take the limit as x approaches 2 from the left side, and the limit as x approaches 2 from the right side. When I come from the left side, I'm going to be dealing with the function 3x plus 1. From the right side, I'm dealing with 5x minus 3. I can just do direct substitution for both of these. So I'm going to get 7 for this first one, 7 for the second one. Because these two values are the same, we know that we have continuity. So we know at this point that we can at least cross off the ones that say it's not continuous. So A would be out because it says it's neither continuous nor differentiable. And then C would be out because it says it's not continuous. So if you're tight on time, you can hopefully at least do that piece and narrow your guess down to a 50-50 chance. Now I've got to check for differentiability. So we need to see if as these two graphs meet each other, are their slopes the same? And this might be really easy for some of you guys to see. In this case, it is somewhat easy to see. But let's show you guys what it would look like to kind of formally do this. We're going to want to take the derivative of both of these functions, because the derivative is the slope. So it's saying as I approach from the left of 2, I'm coming in at a slope of 3. And then as I leave 2, as I go from 2 on, I'm leaving at a slope of 5. Which means that at that point of 2, those two slopes don't meet. There's going to be some sort of sharp turn. The graph's going to take a very drastic and immediate turn from a slope of 3 to a slope of 5. So we are not going to have a differentiable function because sharp turns are not differentiable. So our answer is that f is continuous, but it's not differentiable at x equals -2. All right, let's go ahead and look at a free response question now. Sorry, this is kind of squished. I know it's small on your note card. You will have much, much, much more space than this on your AP exam, but I wanted them to fit on your half cards. So we've got these graphs of the functions f and its derivative f primed. We're looking at just an interval from -1 to 4. Again, as always, make sure you're checking to know which graph is f and which one is f primed. And let's answer some questions about them. So first, I want to find the average rate of change of f over the interval. And then I want to know for how many values of x on the interval does the instantaneous rate of change of f equal the average rate of change. So we're going to start by finding the average rate of change. Now, AROC is not like technically a math, like this is kind of like a made up acronym. So make sure that if you write AROC, you also kind of write what you're doing. F of 4 minus f of 1 over 4 minus -1. That fraction right there is going to be key to getting the point for finding the average rate of change. In fact, if you write that and get the next piece wrong, you're probably still going to be okay. So let's go ahead and calculate that. I'm actually going to stack my work. So f of 4, I'm just going to go ahead and look up my graph. F of 4 is 1, f of negative 1 is negative 2. So I have 1 minus negative 2 over 5. So let's see, I've got 3 over 5. So 3/5 would be my average rate of change. Okay, that's your first point that you get for this one. You get a point for finding the 3/5. And then I want to know for how many values of x on the interval does the instantaneous rate of change hit 3/5. So we're finding instantaneous rates of change. Now we're looking at our derivative. So I'm going to come over here to the graph of the derivative. I don't know why there's a red dot there, sorry. I want to know how many times is this graph, this f prime graph, hit 3/5. So you can think about, like, there's about the value of 3/5. We hit that line, we hit that value twice. So at 2 times, our function's instantaneous rate of change is equal to its average rate of change. So we're just going to write 2 times on the interval. Okay. All right, let's go ahead and jump down to B then. Sorry, it's kind of going in a weird order too. Write an equation for the line tangent to the graph of f at x equals 1. So to write an equation of a tangent line, we need both an x and a y, and we need a slope. So the x and the y should be pretty easy to find. We can just look back at our original function. At 1, the point is 1, 2. So that 2 is going to be my y value. And the slope, I can just look at my derivative slope. So when I'm looking at 1, that's not 1. When I'm at x equals 1, looks like my derivative is negative 2. So my m is going to be negative 2. So again, we're using that derivative to give us our slope or instantaneous rate of change. Once I have that, it's easy sailing. Y minus y1 is equal to m times x minus x1. Don't worry about rearranging it. This is for response, so just leave it like that. Just so you know, for this one, it's only worth 1 point. You get 1 point for this, so make sure that you get all those pieces right. All right. For each of these limits, find the value or give a reason why it does not exist. Now, this is a great question because it tests whether you know the limit definition of a derivative. You will see some sort of question like this on your AP exam. At the very beginning of derivatives, we talked about how to define a derivative using a limit. This is the way you define a derivative using a limit. So really, this first limit, the limit as x approaches 2, of f of x minus f of 2 over x minus 2. This is the way that you find the derivative of f at 2. So that limit is equal to the derivative f primed of 2. Same with the other one. The limit as x approaches 3 of f of x minus f of 3 over x minus 3 is equal to f primed of 3. So I would recommend starting this problem by writing out that you recognize and understand that that limit is really a derivative that they're asking you for. And then we can just go ahead and look back at our graphs and we can see, okay, does f primed of 2 exist? Does f primed of 3 exist? Okay, so let's go ahead and erase those. We don't think they're fractions. And again, I can just look at my graph of the derivative. So I look at this graph, f primed of 2, yep, it exists, and it's 1. Notice that we just care if this point exists. We don't care if the derivative exists there, because that is the derivative. So f primed of 2, that's equal to 1. F primed of 3, looks like we have a little jump over here. We have a jump discontinuity, which would be fine if one of those was filled in, but there's just no point there. So there's no derivative value at 3. So this does not exist. So you want to say it doesn't exist, but you also want to give a reason why. You've got a couple different options. One, you can say that f primed of 3 does not exist. Or probably an even better answer would go back to the original graph of f and say at f there's a sharp turn in the graph, which means the derivative wouldn't exist. Because then you're showing them that you understand sharp turns prevent differentiability. let's look at D. So now we're defining a whole new function. G is going to be the function defined by e to the x times f of x. This is a great one where D doesn't build on anything else you've done so far. D is like a totally different question than the other three. So we want to find g primed of 0. So we better start by taking the derivative of g. So I have g primed of x. I have e to the x times f of x. That's a product. So I'm going to do the first function times the derivative of the second, plus the second function times the derivative of the first. And I'm just going to plug in 0 for all these. So g primed of 0 equals e to the 0, f primed of 0, plus f of 0, e to the 0. Both of these steps are necessary. You want to show both of these steps. This first one shows that you know the product rule. This second one shows that you're plugging in 0. As you start simplifying these following steps, you could probably condense them. E to the 0 is 1. I'm going to check my graph to figure out what f primed of 0 is. So at 0, f primed is 1. And then I want f of 0, so I'm going back to my original function. F of 0 is 3. E to the 0 is 1, so I'm left with 1 plus 3, which is 4. So that would be g primed of 0. And again, let me double check the grading rubric on this and tell you how you get your points. So you get 1 point on this one for finding the derivative, so using your product rule, and then you get 1 point here for finding the 4.